So hello students and welcome again to my channel. My name is Mr. Meshak Ngige and welcome to eMaths with Mr. Meshak Ngige. So kindly consider subscribing, sharing and also commenting to my channel, so that you can help this channel to really grow and it can reach as many people as possible. Now in today's lesson we're going to be checking something called the unit normal vector, and we're just going to jump right into the working. So we're going to check one or two examples. So we know that a unit vector is given by, remember this is a series from something called the gradient. So if you have not watched again the video on how to find the gradient, the grad, then this is the video for you. So now we have this where this one defines, we have the operator and we have the function, and remember we are always dealing with scalar functions. They do not have I, j and k, so you can only get the gradient for a scalar function, not for a vector together. But the outcome will be what? And the outcome of this will be a vector by the end of the day. So now again, so solution. So what do we need to get? We need to get the grad. We need to get the magnitude of the grad. So the grad will be given by, so I'll just write the formula dx. So I'll just include the phi inside dxj plus d phi dy. Okay, sorry, it is y and z. Then we have y and we have z, then we have k. So what you're saying is you have the function, differentiate the function with respect to x, with respect to y and with respect to z, then inputting I, j and k in all the cases. So we start with d phi dx, then I. So we differentiate the function up to this point without the 0 on the other side. Anyway, if we differentiate as 0, still 0. So we have this function here. So differentiating this part from this part to this part here without the 0, we differentiate with respect to x. So this one will give us what? It will give us 3x squared, then we have y. We also have an x here, but the x goes, you remain with 4z what? Z squared. We have an x here also, so you remain with y squared, then we have z. Differentiating a constant gives you 0. Then you're supposed to put I. So I'll leave some space here for the sake of replacing our limits because of the space on the other side. So we have again d phi dy, then we have j. Now differentiating with respect to y, so we have y here, it goes, remain with x cubed, then you have plus, do you have a y here? No, so you go to the next, which is y squared, so we'll drop 2, then you have x, then you have y, then you have z. Right, differentiating a constant again gives you 0. Then we go to the last one, which is d phi dz, then k. So differentiating again the function with respect to z, there's no z here, but we have a z here, so this one gives us 8x z, because remember we have dropped the what? We have dropped the 2. Then we have a z here also. The z goes, you remain with xy, then squared, then you have what? Then you have k. Together. So you should have some good knowledge when it comes to partial derivatives. So now we're replacing at point 1, 3, negative 1, so in every part there. So now we can go in each term at a go. So at 1, 3, 2, 1, 3, sorry, negative 1, and at 1, 3, negative 1, at 1, 3, so you have those three. So replace your values. So your x is 1, your y is 3, your z is negative 1. So you have 1 times 1 squared, 3 times 1 squared is 3, then times 3, which gives us 9. Okay, plus 4, negative 1 squared gives me positive 4, plus y is 3, so 3 squared, and z is negative 1, so you have negative 9. Is that true? Yes, this one 3 squared gives us that, which is 9, and this one is negative, yes, correct. So therefore this one gives you 9, and negative 9 goes, you get 4 what? You get 4i. Go to the next. X is 1 cubed is 1, plus 2 times 1, 2, 2 times 3, 6, 6 times negative 1, negative 6. So therefore we'll have negative what? Negative 5j. Then lastly, we shall have what? Lastly, we have now the last one. So it is 8. 8 times 1 is 8. Then times negative 1 gives you negative 8. Then plus x is 1. Then 3 squared is 9. 9 times 1 just gives you 9. But you have negative 8 plus 9, which gives you positive 1. So we can just say this one is k. Sorry. So you have k. So therefore, your grad will be given by 4i minus 5j plus k. Therefore, again, get the absolute or the magnitude for that, which is 4 squared plus negative 5 squared plus 1 squared. Then you get the what? Then you get the square root, which is given by 16 plus 25 plus 1. Is that true? Yes. So this and this gives you 41. Is it? Yes, it gives you 41 plus 1, 42. So this one is the root of 42. Therefore, your unit normal will be given by the grad, which is 4i minus 5j plus k over the root of 42. So you can just rewrite it and say it is 1 over root 42 into bracket 4i minus 5j plus k. And that is how you find your unit normal. Let's check the second example. Hello students, and welcome again to the second example of unit normal vector. Now, so being given the question, determine the unit normal vector of the surface xyz plus x squared y minus 5yz. Then you have minus 5 equals to 0. Solution. So as you can see, we have said this one is a simple question to handle. All right. So you find the grad, then the magnitude of the grad. So therefore, in this case, what is our grad? It is given by d phi dxi d phi dyj plus d phi dz. Then you have k. Right, together. Let me write them correctly. And again, I'll repeat myself again by saying that your value does not, the name of the function does not necessarily need to be phi. Right, together? Yes. So it can be any other letter. But you need to just know it is just the operator multiplied by the function. Okay. So now, just get our d phi. So we get this part. So we get d phi dx, then I. So differentiate the function with respect to x, then you put I. So with respect to x, the x goes there, you remain with y. Z, with respect to x, you get what? 2x what? Y. With respect to x, there is no x, there is no x. Right, together? So therefore this one gives you I. Then d phi dy, then you have j. Again, with respect to y, you remain with xz. With respect to y, you get x squared. With respect to y, you get negative 5z. Then you get j. Then you have d phi dzk, which gives us, with respect to z now, you get xy, then plus, the second part does not have a z, so you come to the third, which will now be minus 5y. So remember, these are constants. So anytime you differentiate a constant, you get what? You get a 0. Now at point 312, at point 312, at point 312. So what will we have as the outcome? So our y is 1. 1 times 2 is 2. Then we have 2 times 3 is 6. 6 times 1 is 6. So 6 and 2 gives you 8i. Then you come to 3. You come to the next one. So 3 times 2 gives us 6. Then you get 3 squared, which gives us 9. So 6 plus 9 gives you 15. Okay. 15 times 10. 15 minus 10, which will give you 5j. Then you have 3 times 1 gives you 3. Then 5 times 1, which gives you 5. So 3 minus 5 gives you negative 2k. Therefore, your grad will be given by 8i plus 5j minus 2k. Again, get the magnitude of that, which is given by 8 squared plus 5 squared plus negative 2 squared. Then you get the what? Then you get the square root. So this one will be root of 64 plus 25 plus plus 4. Now this one give you, so you have 64 plus that gives you 89. 89 plus 4 gives you 93. Root of 93. So therefore, your unit normal will be given by 8i plus 5j minus 2k all over this. So you have root of 93. So again, you can just simple out the constant 1 over the root of 93 into bracket 8i plus 5j minus 2k. And that is how you get any normal, unit normal vector for a function. Are you together? So thank you and see you in the next lesson.